If you put a cat in a seal box with a device that has 50% chance of killing the cat in the next hour, what will be the state of the cat at the end of the time? Asked Edwin Schrödinger. Actually, it's all about probability. Quantum mechanics started with this incredible phenomenon. Edwin Schrödinger is actually famous with an experiment that he never done. He won the Nobel Prize with only its thoughts. But obviously, Schrödinger ended up with some equations that governs the behavior of quantum particles. Let me explain you further.
What can you see in this picture? This is the famous quantum sphere. Is it magic? Weirdness? How can the sphere be in one piece after a tree? And what is Schrödinger is actually talking about?
Quantum mechanics, the science that is dealing with the behavior of matter and light on an atomic and subatomic scale, and their movement according to probability. Now, let's get back to the sphere. Sphere goes between two sides of the tree at the same time. This always happens in the quantum world. There is a similarity between the lab environment and the sphere. In labs, we create vacuum and a cool environment to absolute zero. That way, we reach the quantum universe. Actually, on molecular level, cells do pretty well on conducting this quantum environment. And here comes the quantum biology. In quantum biology, we use quantum mechanics to describe certain processes of life in numerous ways. Let me explain you some of them. Photosynthesis, a very important chemical reaction that occurs in plants and some bacteria, which uses the energy of sunlight to create glucose. Particles such as electrons often act like waves. Protons hitting the antenna molecule kick up the ripples of energized electrons. These energized electrons then pass from one molecule to the next until they reach the reaction center. Somehow, it uses multiple pathways at the same time to reach the reaction center to find the most efficient pathway. This is called quantum coherence. Enzyme catalysis. It has always been a mystery how enzymes speed up chemical reactions, and it has been found that enzymes transfer electrons and protons from one molecule to another by quantum tunneling.
Here's an example of quantum tunneling. A subatomic particle acts like a wave and it has a probability of permeating from an impenetrable barrier.
You cannot get through in an impenetrable barrier, but in a quantum world, you can. Bird migration. One long-standing biological puzzle that might be explained by exotic quantum effects is how some birds are able to navigate by sensing Earth's magnetic field. Now, the theory says birds use something called quantum entanglement. Inside the eye retina, there is a light-sensitive protein, and inside that protein molecules, a pair of electrons are quantum entangled, means they interact for a far distance and spin according to the Earth's magnetic field.
Thanks for listening. Hope you enjoyed the video.